All right, finally we'll look at developing the molecular orbital diagram for NH2 minus. And NH2 minus is bent. It's like water. It has a nitrogen in the middle. It has hydrogens on the outside. And for N2 minus, the valence orbitals are a 2s orbital on nitrogen, and it has A1 symmetry in the C2V point group. The 2pz also has A1 symmetry in the C2V point group. The 2px has B1 symmetry in the C2V point group, and the py has B2 symmetry in that point group. Over here on the right, we have two possible combinations we can do of two 1s orbitals. They can be in phase, so both of these are unshaded, and that belongs to the A1 point group if we look at our character table. And we can have them out of phase, and this belongs to the B2 point group. This B2, you'll notice, looks just like, the phasing is just like the 2py orbital. Okay, and then first we want to apply our energy criterion. And the energy difference here between the hydrogen atoms and the nitrogen 2s orbital, it's right at 12. So I'm going to go ahead and say that this 2s orbital doesn't bond with the hydrogen atoms. Okay, this is 11.9, so we'll say that it's close to 12. And so this atomic orbital more or less comes over into the molecular orbital diagram, and this lowest lying A1 orbital is non-bonding. Next, we go up and we start combining things. And the B2 combination of the hydrogen 1s orbitals and the 2py can combine with one another in a bonding molecular orbital. So here the two hydrogens and the 2py orbital are same phase, so they match up. This forms a bonding combination. Up here we have an anti-bonding combination. So the 1s orbitals and the 2py are out of phase, and this is the anti-bonding. So we have a bonding and an anti-bonding combination. With the other A1s, so we have an A1 from the 2pz, we have an A1 combination of the hydrogen 1s orbitals, we get a bonding and an anti-bonding combination of those. And then what we're left with is the 2px has no combination of hydrogens that it matches with, so the B1 simply walks over into the middle of the diagram. And then finally, if we wanted to populate this with electrons, we have 8 valence electrons in this system, so 2, 4, 6, 8. And so now for this molecular ion, we have 2 electrons in the 1A1, 2 electrons in the 1B2, 2 electrons in the 2A1, and 2 electrons in the B1 orbital. So here's our 2 lone pairs that would be in the Lewis structure, one of them being mostly the 2s orbital on nitrogen, the other being this unused 2px orbital on the nitrogen, and then here's our 2 bonds. Okay, one of our bonds is represented here, our other bond is represented there.